Okay, afternoon. So my name's John Ronco. So I run product and marketing here at SiFive. I'm based in Cambridge in the UK, which is suspiciously close to Arm. And that's because I was there for many years. So I used to run product management for the CPU group at Arm for many years. So I understand what it takes to build a successful IP business, and I understand what it takes to ensure customer success. And ultimately, that is what it's all about here at SiFive. It's about how do we provide technology to our customers to enable them to build systems that meet their needs. So Patrick talked a little bit about sort of the three different elements of compute that we talk about. So the embedded processing, the high-performance CPU, and the AI processing. So we have products we have product families that cover each of those. I'm going to talk through a little bit about some of what we're doing in the embedded and the applications processors, and then Kirsty's going to talk about AI after that. So the last couple of months have been quite busy. We've had a number of announcements that you may have seen around our next generation of processors for embedded, the Gen 4. We did some announcements around the ISO certification that I'll talk about in a minute. We announced a new development board, the SiFive P550 Premier, and we announced a new processor for infrastructure. So I'm going to talk a little bit about, recap some of that, and talk a little bit about the direction of where we're going. So for the fourth generation, so our essential products are our family of 32-bit, 64-bit embedded products that we've been shipping since the beginning of SiFive. And these have been super successful. They've been deployed. They're a very large chunk of the billions of chips and the many design wins that Patrick talked about. And they vary from big to small, all sorts of different performance points. So what we announced a couple of months ago was we announced the fourth generation of those products. And we've made various changes in terms of improving PPA and adding new features as driven by customer engagements. Now, one of the unique things about the way SiFive builds products is our generator technology. And that's really had kind of like two impacts in terms of what you see here with our essential products. The first is when we came out with Gen 4, we were able to refresh all 8 products at the same time because of the way they're all built off a common code base. But also because of the way we have the generator technology, we have a very wide scalability and different configurations that can be built, which means that different customers have different needs in terms of what they need for these embedded products, in terms of how they connect them up into their system in particular. And what we're able to do is, even though nominally we have 8 products as part of our essential family, each of those products has many, many different configuration points, much more than you might get from a traditional IP provider. And that's one of the reasons why these are so successful. And that may not have been entirely obvious from some of the PR that we did. Now, as you may know, Arm recently decided to defocus their investment in the embedded space and redeployed a lot of the engineers that were working on Cortex-M and Cortex-R. And I think you can see that as indicative of a couple of things. It's indicative of what has already happened in terms of us and RISC-V winning in the embedded space, and it's indicative of where they and everyone else sees going in the future. So this is a space where RISC-V is already winning, and we expect it to continue to do so. From our point of view, we are continuing to invest. We are already working on the 5th generation. We've already delivered some of the early drops of those to customers. And we're expecting to continue to expand this product line going forward. Another announcement that we made was the ISO certification. So we have some automotive products that are some of our essential products that have additional features for our automotive customers. And what we announced is that we had products that were certified both for ISO 26262, for functional safety, but also for 21434 for cybersecurity as well. And if 21434, if you're not familiar with it, is a relatively newer standard than the functional safety. But it's basically the same thing in terms of it enables us to provide certification to our customers and kind of assurance to our customers about the quality of the products that we're doing. And we were very proud of the fact that we were the first IP provider to deliver both of these certifications, so both 26262 and 21434. And to be really clear, that's the first IP provider of any CPU architecture, showing that from a SiFive point of view, we're obviously leading in the RISC-V space, which is what you might expect, but we're starting now to lead across the industry as a whole, not just within the RISC-V space. And in terms of where we're going next with automotive, we're continuing to expand the portfolio. We're continuing to do more products that have automotive capabilities, not just in embedded, but also for high-performance CPUs and for AI processing as well. Moving on to high-performance CPUs. This was a product, the HiFive Premier P550 board. This was a product that we announced a couple of months ago, and we expect to be in developers' hands very, very soon. I think we'll talk a little bit more about this in a minute, but in terms of the RISC-V as a standard and the ecosystem is really starting to mature. And as that happens, having the availability of high-quality reference boards that are fully compliant with the standard and that everyone can use as a reference becomes really important. So this is a first of several boards that we're going to be announcing over the coming months and quarters. So expect to see several more of these, because our goal is very much to be the reference within the RISC-V world. We're obviously not the only RISC-V supplier, but our goal is to be out there with the high-quality reference platform that is available for developers to use. And then the last announcement that we made back in August was we announced our P870D, which is a high-performance CPU that's optimized for infrastructure use cases. This is our third generation out-of-order processor, and it's added in features that are needed for infrastructure, so like RAS capabilities, but also the ability to scale up to very large systems. This is the first product that we've got that has also used Amber Chai as an interface standard. So we're enabling customers, we connect through a Chai bridge from our CPU clusters to enable customers to scale up to very large core count systems, both within a single die and across multiple dies in chiplet or multiple chiplets. And it's a very exciting product. And what might not be clear from when we talk about it in the PR, it's much more than just the CPU. So from a SiFive point of view, we obviously provide the CPU IP, but we're providing lots of the system components, lots of the software elements, and really thinking about the full system that customers have to build. In terms of where we go next with this, then we are expecting to continue to invest in high-performance CPUs, to continue to push the boundaries of performance. But actually, perhaps what you're going to see even more of now is a greater emphasis around ecosystem and software, because, as I say, the standards are very much maturing from a RISC-V point of view, and it's about how does the rest of the ecosystem matures as well. And so there's a lot of engagement going on with RISC-V International standards, and I'll talk about that in a minute. So I mentioned the system. So this is a bit of a busy chart, but that we released as part of the P870D launch. But the important point, I think, to take away is that there's many elements other than the CPU. So yes, the CPU itself is very important, but there's lots of other elements in the system. And from a SiFive point of view, we are providing lots of these building blocks for our customers. Now, we're not trying to provide everything. We're not trying to limit our customers. We're not trying to say, right, this is a one-size-fits-all system, or this is a cookie-cutter approach. But we're very much trying to understand the whole system and provide lots of the critical building blocks so that they can build something that's differentiated for them. So in the P870D case, we obviously have the clusters. So we obviously have the clusters of the CPUs. But then we have this large Uncore Agents block as well that provides lots of the other critical elements that you need, whether that's the interrupt controller, the debug and trace, the timekeeping, and some of the system elements that are needed for customers to pull together a chip. We also have, at the bottom here, we also have the IOMMU, and we also have the WorldGuard gadgets for providing security. So what we deliver to customers is not just the CPU, it's all of these four elements, and also software packaged around it as well, to help them build these complete systems. One thing that's really important to say here is talk about standards. So our mission at SiFive is to provide the best implementations of standard RISC-V. We are not looking to provide proprietary extensions or special lock-ins or anything like that. We very much believe that the value of RISC-V as an open standard is that it is an open standard and there's commonality between implementations. And that we see our role as an IP provider is to provide the best possible implementations of it. And we do this, and we're also very heavily involved in leading and driving the standards within RISC-V International. Obviously, we had the original founders of RISC-V, and since then, it's now a much more collaborative effort across RISC-V International, but we're obviously heavily involved in lots of different elements of the standards. And I think you can think about the standards here in terms of two elements. You've got the instruction set itself, and then you've got the broader system. From an instruction set point of view, we have ISA profiles, which are groupings of all of the different extensions that are available in RISC-V into a standard set that then can be relied on by the ecosystem. And the latest profile that's coming out in a couple of months, which has been ratified now and finalised, is the RVA23 profile. Now, this is quite an important milestone. So this is a major release, and it includes mandatory requirement for features like vectors and hypervisors, and also is adding new capabilities like pointer masking into the instruction set profile. And this provides quite a high baseline level that then will be used across both the server markets and across the consumer markets as well. And we're not expecting there to be another major release for a little while now, because this is kind of a major release would add new mandatory features and new mandatory instructions. There will obviously be lots of optional extensions that get added, but we're seeing RVA23 should be a pretty mature baseline that will then be relied upon across multiple markets. So that's an exciting milestone. But as I say, it's not just about the instruction set itself, it's about the broader system as well. And one of the things that ARM did pretty well, I have to say, when ARM was getting into the server space, was defining beyond the instruction set. So defining the platform, how it boots, how security works, how the systems need to be put together. So things like the SBSA and the SBBR that ARM did. So RISC-V is doing the same thing. So these initiatives are underway within RISC-V International to standardize around the server platforms that are needed to make sure that these things are common. And from SiFive's point of view, we're playing a leading role in defining these standards, and we're wanting our products to be fully compliant with these standards. So why is this important? It's all about the software. So I'm sure many of you know John Masters, who was formerly at, never heard of him, formerly at Red Hat, but now at Google. The phrase he used to use all the time was, you've got to make software boring. And it's a really good way of saying what needs to happen here, is that you need to get to the point where software just works on the platform, and you don't have lots of interesting incompatibilities you've got to deal with. And so all of the work around the profiles, all of the work around standard platforms is with that goal of making software boring. And this is relevant for servers, but it's also relevant for the consumer space. And we've seen a really good progress on this. So just to give you a couple of examples, so Android on RISC-V is now basically ready. It's ready for OEMs to adopt products. And it's aligning around the RVA23 profile as the baseline for platforms and for app developers as well. Ubuntu, we are having a long partnership with Ubuntu, with Canonical, and Ubuntu is going to be available on all of the Hi5 reference boards going forward as a standard platform. So there's a lot of maturity that's now coming into the software ecosystem, and that is all built on this foundations of the ISA and the platform standards are starting to mature. And our goal, as Patrick mentioned RISE earlier, is really just to collaborate across the ecosystem for all of these players who are developing the different software components. So just talking a little bit more about what we do in software, because obviously software is super important. So we have over 100 software engineers here at SiFive. doing various bits and pieces. With every release that we make, we obviously deliver lots of software to our customers, and we deliver kind of all of the key components that they need to help them build their systems. But from a business strategy point of view, we're not seeking to license that software. We're not seeking to sort of generate revenue streams from it. Rather, we're seeking to leverage open source as much as possible. Hence the emphasis on standards, hence the emphasis on kind of collaborating with the ecosystem. So what we do, we upstream as much of it as possible and basically enable the ecosystems. Within our engineering team, within our software engineering team, a lot of what we're focused on doing ourselves is kind of like the core technologies like compiler work, but we also do performance libraries that are very much tuned around the SiFive microarchitecture. But beyond that, it's then a lot of collaboration. So the example here is Nathan Eggy from Google, who's been doing some optimization work around codecs using RISC-V vectors. And so this is a great example where Google is leading the work, but we are playing a supporting role in helping them do what they need to do. So we do that across the industry with lots and lots of different ecosystem partners. And as I mentioned, we collaborate through the RISE consortium as well to help drive lots of enablement around open source software. And beyond software, it's not just about us. There's a couple of other announcements that we've had over the last few months. So today, actually, Wind River announced their Alexia Pro enterprise-grade Linux, and they've announced that it will be supporting RISC-V as well. I mentioned earlier the Amber Chai as a platform as a sort of an interface standard that we're using to help customers build out systems. So we've expanded a partnership with Arteris, who provide a Chai compliant NOC, and we're building reference systems using the Arteris NOC, and also working with a number of mutual customers who are building systems combining SiFive with Arteris. And the last one I wanted to mention, we did an announcement a couple of weeks ago with the company PQ Shield, working on post-quantum cryptography. And there's a specific announcement of what we were doing with them, but there's a more general point here, which is we have a number of collaborations, a number of threads around post-quantum cryptography where we are working with academia and others on this. And the point I wanted to bring this up for was really just to say, we're not just working in the here and now. This is not just about products on the shelf today. We're seeking to take kind of a leadership role across the industry on some of the important topics like post-quantum cryptography. Okay, so to pull it all together, I just wanted to kind of give you a summary of where we are going from a product portfolio point of view. So I said we have product families that link to the elements of compute, so embedded, high-performance CPU, and AI. And we also have a product family around automotive versions of those three. We've got continued investment across all three of these. As I mentioned earlier, some of the incumbents seem to think that there's no longer a value in the embedded space. From our point of view, that's very much not the case. So we see that there's a lot of opportunity to expand our business in embedded, but we're also investing heavily in high-performance CPU and AI as well. And across the markets, so Patrick mentioned these four markets already, and what we are trying to do is enable the different building blocks to enable our customers to build the right solutions for each of these four markets. So this is kind of a summary of our portfolio. So these are the products. On the left-hand column here, you have the established products that are already in silicon. And it's split up in terms of the orange is the performance CPUs, the green is the AI, and the blue is the essential and the automotive. So the left-hand column is what's established. So these are the products that are already in silicon. The middle column is the new stuff. And then the right-hand side is kind of just where we're going next with some of these. So for the performance CPUs, I mentioned that P870D is our third generation out-of-order processor. And what we are going to be doing going forward is more of these. So there's going to be more processors announced in the coming months that are maybe more on the consumer side, but are also leveraging the RVA23 standard. And out-of-order processors are hard. They take a lot of investment. But as I say, we're on our third generation now, and we really believe that we're achieving very competitive PPA, very competitive feature sets that can be used across a whole range of different markets. Kirsty's going to talk more about AI, so I won't dwell on that. And then on the Essential side, as I say, we've just released our Gen 4 Essential update with refreshed all of our products that are in this space, in the embedded space. And we're already starting to work beyond that. So we're already delivering the Gen 5 products to some early releases of the Gen 5 products to some customers. And we're going to continue to expand this product space and create different combinations of features and products that don't exist today, based on customer demand, based on our customers wanting us to deliver different proof points. And then on the automotive side, again, we're looking to expand across the range of the different products that we have. We're looking to add automotive features to more of our products. And then just the point at the bottom there to say that, remember, this is just the CPU that's on this chart, but there's a lot of work around the system IP, and around the software investment that we're making, all with the goal of saying, how do we help our customers build those systems? So that's it for me, just to wrap up. So as I say, our mission is very much how do we enable customers to build optimum systems for their use case, for the market that they're targeting. And we see ourselves as the gold standard for RISC-V. We have the broadest portfolio of CPU, system IP, and software that we provide, and we enable our customers to build many, many different combinations of products. And that is our intent, is to kind of continue to be the leader there and be the leading reference platform for RISC-V. And we're investing across all of the elements, all the different elements that we talked about of compute, and continuing to lead the RISC-V standard, and also to show leadership beyond RISC-V into the broader electronics industry.